Hello, grade 8 learner. Welcome to another video lesson in mathematics, where we will be discussing an application of the concepts of triangle congruence. This lesson is based on the K-12 curriculum competency. The learner applies triangle congruence to construct perpendicular lines and angle bisectors. It's another great day to learn, so prepare your pen, paper, and module as you start watching and learning from this video lesson. For this lesson, refer to your Quarter 3 Math module entitled Applications of Triangle Congruence. Given the following figure, we are going to find the value of x and the measure of side FD. We begin by observing the problem. First, we identify the given and what is asked in the problem. From the figure, we see that side FB has a measure of 5x units and segment FD measures 2x plus 24 units. We observe also the right angles at B and D as well as the congruent angles BCF and DCF. Next, we recall what an angle bisector is. An angle bisector is a segment that divides an angle into two equal parts. From the figure, we see line segment CF dividing angle ACE into the congruent angles BCF and DCF. Let us process what we know. To solve for what is asked, we can use the angle bisector theorem, which states that if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. Thus, point F, which is on the bisector CF, is equidistant to points B and D, which are on the angle ACE, which segment CF bisects. The angle bisector theorem is an application of triangle congruences. To show that, let us prove that side FB is congruent to side FD. To construct our simple proof, we identify two triangles, triangle BCF and triangle DCF, that contain sides FB and FD. We begin with a given, which is segment CF is a bisector of angle ACE. From the definition of angle bisectors, we can state that angle BCF is congruent to angle DCF. From the figure, we can see that side CF is common to both triangles. Thus, we can say that side CF is congruent to side CF by reflexive property. Looking at the parts which are proven congruent, and because there are right angles in the triangles, we are going to use the right triangle congruence theorems to prove that triangles CEA and CEB are congruent. We see that a pair of acute angles and the hypotenuses of the right triangles are proven congruent. Thus, triangle CEA is congruent to triangle CEB by the high A theorem. Now that the triangles are proven congruent, we can say that side FB is congruent to side FD through CP/CTC, or that congruent parts of congruent triangles are congruent. Now let us solve for the value of x. We apply the angle bisector theorem in our solution for x. Recall that we have proven that side FB is congruent to side FD. Therefore, we equate their measures, which are 5x equal to 2x plus 24. To solve for x, we need to put together all terms with x. So, we transpose 2x, which results to 5x minus 2x equal to 24. We simplify the equation by subtracting 2x from 5x to get the resulting equation 3x equal to 24. We divide both sides of the equation by 3 to get x equal to 8. Next, to solve for the measure of segment FD, we look at the figure, where we see that segment FD measures 2x plus 24. Since we know now the value of x, we substitute x with 8 in 2x plus 24. We multiply 2 and 8 together to get 16 plus 24, which we add to get the result, which is that the segment FD measures 40 units. Let us state our conclusions. Given the figure where segment CF is a bisector of angle ACE, we use the angle bisector theorem to solve that the value of x is 8 and the measure of segment FD is 40 units. Congratulations for finishing this video lesson. Now apply what you've learned by answering the activities in the activity sheet. Happy learning! We'll see you again in our next video lesson.